Yes, you can.
Like even after being in the fridge all this time?
I probably wouldn't. I feed it to my dogs, but
Maybe Hero should eat it.
Wouldn't the heart
Who?
muscle be really
My husband.
tough?
it's very tough.
I would assume it'd be like,
Yeah,
Probably good for you though, wouldn't you think?
I mean,
it's probably pretty lean
Yeah.
compared to a lot of marbled steak.
That looks better than our lambs.
I know, see, that's why it's neat.
Better than our lambs?
The
lamb
sheep hearts?
Oh, sheep hearts.
Is that what you mean? By lambs?
I think so.
Yeah,
That's what I
Baby
mean.
sheep is called a lamb, right?
Yeah, but you didn't have baby sheep hearts
We did.
for the section. You had full type. Yeah.
I get sad just every time. You're
I know,
vegetarian.
me too.
I actually like this stuff a lot more than I thought I would
Big
though.
blood clots coming out here. So.
It's better than pictures in a book.
Yeah.
I think I saw them having to eat blood clots one time on Fear Factor. It was kind of gross.
Oh, God.
Gross.
What is it?
Fear Factor.
Fear Factor.
What
See,
did they
Fear
do?
Factor would be better if it wasn't just about eating gross stuff.
Yeah.
I mean, really. That's not fear, that's just disgusting. All right, so heart anatomy. Anterior surface, so we reflected back the pericardial sac. And so this is that landmark for the anterior surface of the heart. That's the,
Interventricular sulcus.
and the arteries you would call,
oh, hang on, I know these. They feed the heart muscle, right?
yep, collectively. Yeah, so they branch off
Oh, so
the
the three
aorta.
ones, the
the
brachiocephalic, trunk.
So here's an artery coming off the aorta. So collectively, they're all known as coronary arteries. The weird thing is, the veins that drain the heart that are on the surface, that drain right here into the coronary sinus, are called cardiac veins. So coronary arteries, but cardiac veins.
Oh, okay. You guys got that?
So that sulcus lies roughly over the top of the interventricular septum. See that? Okay. So that makes this the right ventricle, this the left ventricle. And you can see the difference in the thickness of the walls of those two pumping chambers. So they actually hold the same volume of blood. It's just that this only has to pump to the lungs, and this has to pump through the rest of the body.
So smooth.
Yeah, so lining the chambers, covering the valves, and continuous with the lining of all the blood vessels is endothelium in the blood vessels, called endocardium, lining the chambers of the heart. And then going into the right, oh, this is convenient. Going into the right ventricle is the right atrium. So that's the chamber. And into the left ventricle, the left atrium. And on the left, having two cusps, that atrioventricular valve is the
Bicuspid.
bicuspid. On the right, having three, but also having an R in its name, tricuspid. So right tricuspid. Good. And the bicuspid and tricuspid valves do what?
Prevent backflow into the heart.
Prevent backflow into the atria. Yep. And these little tendon-like cords, chordae tendinae, and at the base, these little finger-like projections of muscle, papillary muscle. Yeah. Yep. Papillary muscle. There's a good view there. So it's part of the muscle portion of the heart wall. What do you call the muscle portion of the heart wall?
Myocardium?
Myocardium. You should not be
Sorry.
answering all these, Kyle.
I'm really reviewing for myself. I'm
Whisper
sorry.
them to Kate.
Okay, I'm sorry.
So myocardium, papillary muscle is also part of myocardium. So when the ventricle contracts, right, and because of the arrangement of muscle, the heart literally does this kind of twisting chin up to wring itself out, which means the apex of the heart comes closer to the atrium, which would make these go slack, right? So because papillary muscles are part of the myocardium, they contract and pull down even though the muscle is moving upward. Does that make sense? And it keeps these cords taut, so it's like pulling on the cords of your parachute, trying to keep your parachute from collapsing. So that's the job of papillary
That's
muscle.
what I was trying to explain to you earlier with the dissection over there. It's kind of, it's hard to.
It's
at a cross.
counterintuitive.
Yeah.
It's the
It
opposite
is.
Yeah.
of what you would think.
Yeah, but it's part of the muscle, so it contracts the same time the rest of the ventricle does. But the heart does this kind of twisting chin up when it contracts. And if these cords got slack, then the valves would fail. and blood would go back into the
backwards,
atrium.
yeah.
So instead, as soon as you bring that bottom of the heart up closer to the atrium, you need to be pulling down on the cords, which is what the papillary muscles do.
And does that ringing up motion have anything to do with like how the action potential is moving through the heart, or is it just the way?
To a degree, because when the SA node fires and it goes to the AV node, then down the interventricular septum, right? When it branches up, it starts delivering voltage to the myocardium first at the apex and then spreading up both walls of the ventricles. So you contract here, but the twisting action is because the muscle fibers are arranged in kind of a broad spiral.
Okay.
But you do begin ventricular contraction down here, because it wouldn't make any sense to start contracting up above,
No.
right? It'd be like squeezing your toothpaste tube from the top.
I do that.
The worst kind of person.
I know.
So we do
Every once in a
have,
while,
do you
fix
remember
it.
trabeculae in spongy bone?
Yeah.
See, we've got some trabeculae here too,
What,
right?
what is it?
Trabeculae are just these kind of buttressing branches like this that give the ventral kind of a spongy appearance, right? And it may help prevent some overexpansion, but it also actually may add to some sponginess in the ventricles. So if you're looking at an amphibian heart, there is no interventricular septum, but it's very spongy. So if you can imagine dipping your kitchen sponge into a puddle of red water and a puddle of blue water, and you just put it straight in, you'd have red water on one side, blue water on the other side, and very little mixing in the middle. So amphibians only have one ventricle, but they can still keep relatively separate pulmonary and systemic circuits because it's
So
spongy.
they have
this
like a
is,
flap that like prevents blood going to the lungs or something.
they have a
so-
spiral valve
Okay.
that does help
Uh-huh.
guide that red and blue water, if you will,
Yeah.
into the appropriate arteries, because they do have separate pulmonary and systemic aortas.
Okay.
Yeah.
Really? Well, what keeps them from mixing together?
The sponginess of the ventricle and then that spiral valve.
I think it does. A lot of it does mix
Wow.
together, though, right?
There is some mixing together, and it's
It's not
okay
as-
because the skin is a huge respiratory organ in amphibians. So you can send your systemic blood out to the skin and still do gas exchange.
Huh?
Alrighty, so leaving the, what's this chamber again?
Right ventricle.
Right ventricle. So leaving the right ventricle. So I don't want to go back up into the atrium. I want to go here, right? What's that?
Pulmonary.
Close.
Pulmonary artery. So that's a pulmonary artery,
Where's it
pulmonary
going?
trunk. If you reach in here, you can start to feel the branches going to
The lungs.
the
Oh,
lungs
wow, that's nice.
for gas exchange. And then leaving,
On the sheep, it's not so
yeah,
nice.
and in fact, here,
See?
that is the semilunar valve of the aorta.
I gotta see this. Can I pull
Oh,
it
okay,
apart
cool.
for you, or do you guys see it?
You could
Yeah.
poke at it with the,
Oh,
yeah.
with
You
the,
see it?
yeah. It's kind of floppy, yeah. Yep.
We saw one on the sheep from the other side.
And so here is the aorta. So it's very thick walled, right?
Which one?
Where my finger is.
And where's the other one where you were?
That's the pulmonary trunk.
Okay.
Here's the aorta.
Yep.
And you
they're
can start
both
to kind
really
of,
thick.
and if we do this, you start seeing it coming out the branches.
Oh, cool. That's nice when it's so big.
Yeah. And so notice that the arteries don't collapse even if they're not filled with blood.
That's how you tell they're arteries.
Yep. Lost. Alrighty, then the other interesting
That's
thing
pretty neat.
is, again, this is right atrium, so this thin-walled vessel coming in, right? That's superior vena cava.
Collapsy. Mm-hmm.
And then, even more interesting,
Inferior.
that's the inferior vena cava. And it is
Doesn't even really
completely
look like a
collapsed.
vein.
Nope. I mean, you can...
Oh, they didn't.
When I used to
like,
do this
oh,
without gloves on, you could actually see the details of my fingernail. I mean, it is so
Wow.
thin-walled. Yeah,
Huh.
yeah,
You used to do this without gloves on?
I did. It's just a pig.
What changed?
Peer pressure. Yeah, so that's how thin-walled that inferior vena cava is.
Huh.
And big,
I just
right?
feel like that looks like it's really germy.
Really?
Just like meat.
Yeah.
Yeah.
Isn't meat pretty germy?
Nah.
As
None
long
of none of this should have any bacteria on it at all.
Really?
Yep. I mean,
I
shouldn't.
feel like it. Weird.
Yeah. Okay.
That's
So
cool.
we got the unpaired cartilages, the thyroid, oh, the epiglottis, and I forgot to point out the back wall of the larynx plus this first ring, that's cricoid. So on your
That's
TA
a
sheet,
humongous
if you
thing.
follow the TA sheet, you won't miss anything like I have, right? There's TA notes in in the student's packet, and so just go through that list and have them check them off as you go along and make sure that, yeah, you don't miss anything. And then tracheal cartilages, and if, I'll just do this in one little section here. So you can see how they're incomplete rings.
Oh, yeah.
And they'd be further apart.
That's nice.
Yeah, they'd be further apart in the thorax because the thorax is pulling everything out, right? So, you know, it's the kind of thing where I would encourage students to just put gloves on so they can feel. Yeah. Good. All right. So, visceral parietal pleura, pericardium, chambers, yep, membranes. Okay. I think that's
Now the machine.
I think that's basically it. Now it's now to blow it up. Yeah.
I kind of want to be on this side. Excuse me.
All right. So there is a
Wow.
Is it going to be
Pardon?
loud? Should we move the knife?
The scaffold.
scalpel. Yeah, so it doesn't go flinging out of there.
It's going to be a really long video.
Oh,
I'll
sorry.
send it to you, Kate.
So
maybe stop.
I
and
would
we'll
just
do us two. Just stop now. And
Well, I'm
then,
already at 11 minutes. I might as well just keep going. I can like
put
upload it to
below the
YouTube or
slit probably
something.
and
Okay.
just kind of hold this. So you
Really?
yeah, just turn it on and then
Okay.
turn it off when I tell you. So
Okay.
inhale.
I'm gonna do it.
Go. Oh, I got a hold. There we go.
Oh my god, that's so cool.
Oh, that's cool.
What?
There, that's good.
Oh my
It's crazy how
god.
the color changed.
Yeah.
Like,
Can we do it one more time?
Yes. So you must have a hole in here somewhere.
Oh, poor baby.
I don't
It
think
might
it's
be
gonna
right
make
there. Yeah.
I
So
know.
so just kind of hold here and it works fine. Okay. So expanding
so
the
cool.
thorax. Yeah. And then elastic recoil. So that's why you. And now it's easier to see the dome shape of the diaphragm, right?
Yeah.
Yeah.
One more
And then
time.
you can feel yeah.
That is so neat.
And you could probably just leave it running, because as soon as you let go, air comes out. Yeah, I'm just looking for a bleb, but I don't see any because he's clearly a non-smoker.
A bleb?
Yeah. So,
what is a bleb?
so a bleb. Oh, there's a little bleb right there, but it's because it's yeah. See that little air? Okay, ready?
No, I don't see what you're doing.
Okay, go ahead and
What
inhale.
is it? Okay.
Inhale again. Oh, that's so cool.
Oh my god.
That's insane.
Can you do it till it like blows up actually?
Oh, it didn't do it
I
again.
don't think we want to.
But could you do that?
You
Like is
could.
it-
You
Oh my
could.
God.
Look at all these little
Yeah. So what is this?
arteries.
So here's something I want to do. Here there are two tubes. Which was which?
This is the esophagus.
Yep, esophagus. And this,
Trachea.
I don't think,
That's the
because that's going past the
aorta,
lungs.
isn't it?
Is that
that's
your?
the aorta. So all of these are intercostals.
Is this just
cute.
is this
They
just
look like
adipose
little
tissue?
Just adipose
That's
tissue. There's a couple little lymph nodes embedded in there, but yeah, adipose tissue. Yeah, so that's a good thing to identify the two tubes on the back
You're in
side.
charge, Lee.
Can you blow
What?
it up again?
She's gonna go study.
Back.
I'll probably just stay.
Really?
Yeah.
Do you have lab start at noon?
Nope.
Oh, okay.
1
1?
p.m.
Oh, 1. Okay. Alrighty.
that it?
That's it. Yeah.
Cool.
Yeah. Oh, a bleb is when the visceral pleura lifts off the lungs, and it creates a potential source of friction because they are supposed to slide along each other in the
Yeah.
thorax. And if you bust a bleb, then all the air leaks out into the
Into that.
thoracic, into that pleural space, and that portion of the lung can collapse. So that would be a pneumothorax if you got air.
Oh.
So similarly, you have some blunt trauma to the chest or penetrating trauma, and you puncture into the pleural cavity. And in either way, air from the outside or air from the lungs gets in between visceral and parietal pleura, separates them. The lung will collapse because of all this
So
elastic
are the
recoil.
pleura held together just by tension?
Just surface
'Cause-
tension.
Okay.
Yep.
Because of
Just
fluid
surface
in there?
tension.
Now, what?
Yeah.
One student asked me, how would they remove a tumor from inside a lobe? Do they penetrate the pleura and then
If,
seal it
yeah,
up?
so it kind of depends on where it is. They might be able to go endoscopically because it is usually the epithelium. And so depending on how deep it is,
what you could see it from inside.
you might be able to get it from going inside
And then they just kind of cut it and suck
and
it out.
cauterize and, yeah.
Oh, okay.
Yeah.
It was the size of a golf
But
ball.
if it's big, they may have to go through the body wall, and then your lung is collapsed, and then you have to be hooked up to suction to suck out any air and fluid and wait long enough for the visceral pleura to stick to the parietal pleura.
That's what I thought.
That's crazy.
Do they
you still
breathe
filming?
for you then
Yes, I
while they're
I don't
doing
break
that?
it.